Hello friends, welcome in Java 8 series with programming. So here we'll discuss another concept in Java 8, that is functional interface. And what is functional interface? Why we are using this functional interface in Java and what is the benefit? We'll discuss all details with the use cases also. Many programs I'll write at least two or three use case. We'll see practically. So first of all, what is functional interface? So functional interface in Java is an interface that contains exactly one and only one abstract method known as SAM, single abstract method. So this is the only condition for functional interface in Java 8, right? And this interface mainly we are using what? To invoke lambda expression. Main purpose of this functional interface to invoke lambda expression, right? So yeah, and the key characteristics is, as I already stated, that what only and only one abstract method is there, but we can have multiple static method, multiple default method we can have that also practically. And there is one annotation. Annotation is nothing but @functional interface. This is optional, but I would say we should use. Okay, yeah. So let's start practically. Okay, so I'll create one Java class. Okay, Java class, and what is demo 1 for what? Functional interface, right? Okay, so suppose we have one functional interface. Okay, and we want what? We want to square a number. So first of all, I'll create interface. Interface, and interface is what? I1. Okay, and this interface contains one abstract method, and that is abstract method what? Void square, SQUARE, square it, and it taking as a parameter what? A. Fine, better I'll write this. This is returning integer. Okay, so this is your functional interface, right? I'll write the annotation. This is, I would say, recommended. See, functional interface, right? Now we'll write main method. Okay, and see how we are going to apply functional interface, to implement functional interface by using lambda expression. So how we can do? See, I1 is the interface, and this interface has one abstract method, that is square it, right? So I equals to, this is a reference, and then a, and this is lambda expression, and what we need to provide? A into A. So this is implemented. This is the just one liner implementation for abstract method, and that is nothing but square it. Now how we can call? See, SYSO square, square of number, square of number plus what? I is the reference, I dot square it, and I'll provide 5. Sorry, 5. Save this one, run this program. See, square of number is 5, 25. 5. So this is the very simple implementation of this interface. And suppose traditionally how we are, if we are going to work in traditional way, then how it would happen? Let's see in the same. So I'll create another class here, demo1 by using traditional way. Okay, fine. And what I'll do, see, so this is our traditional way. Let's see here screen by screen how we are going to implement. So suppose we have one interface. See, interface was I2 is there, and I2 has same method, what, int square it, square square it with the integer parameters like x. Fine. So this is your interface, and same interface if we are going to implement, then we require one class, child class. So the child class will implement what? Will implement this interface method, right? So we can create the child class test, and implement, we need to use implement keyword and then I2. Fine. And if we mouse over, then what it is saying? Add unimplemented method, right? So we'll add unimplemented method. How we can add? See, so public, because whatever interface it is public static, I can say this is by default public, so public here will int, right, and square it, we'll copy the same things, square it, and what will return what? X into x. Fine. So this is the implementation of your square method. Fine. Now what we'll do, we'll create main method, and then with the reference of I2 we'll create object I2 equals to new test. Fine. The object is created. Okay, so what it is saying, including TW. Okay, this is what it is saying, no including braces, no include type demo one is accessible, must qualify allocation with an including stance. Okay, what I'll do, cut this one. Okay, I'll provide here. Now this is fine. Okay, because public class must have main method, that's why, because see, this is the child class. Now it is fine, no? And then I2 dot what? Square it. See, square it, and we'll provide what? 5 here again. And because this is returning integer, so what I'll go? Square number, SQ and square number, and the nature of this number is integer. Fine. Now we'll print this one, SYSO. Okay, and SQNum. Run this program. Run as Java application. See, 25 is there. Let me change the number. 6. Save this one. Run again. 36. Fine. So see the difference between traditional programming, what earlier we were doing to implement interface, and what now we are doing after Java 8 feature. See, this is just one liner implementation is there, and here we need child class, and then we can implement the interface, right? So there is only one condition for functional interface. We can have only one abstract method, and we can have multiple static, see, static int addition int a comma int b, right? And we can provide what? Return return what? A plus b, fine. And we can provide the default default int subtraction sub, right? Int x comma int y, and in the same way what we are doing, returning x minus y. See, we can have any number of static and default method, and that we can have body also, but because this is the abstract method, suppose we are providing two abstract methods, then see what it is saying. Square it1 and okay, and what I can do, b. See, here we are getting what? The target type of this one must be functional interface. Okay, suppose if we remove this one, see what it is saying. Still, so we must have functional interface, means only and only one. And if we'll comment this one, see, issue is gone here, right? So this is about the functional interface, and use of functional interface is to invoke lambda expression, right? I'll show you one more use case in next video, right? So for this video, thanks a lot.